Hello everyone, this is Professor Warren again. Today we're going to discuss basic IP addressing, but we'll be focusing on Class A IP addressing. And we'll be talking about IPv4 addressing. So if you take a look on the screen, you'll see I have IPv4 addresses. They're 32 bits, 4 octets. Each octet has 8 bits. It has two parts, a network and host. Very important for you to know. Have 5 classes. It uses dotted decimal notation. So when you put it into the computer, it uses dotted decimal notation. So you enter a decimal value when you put it in. So the parts of an IP address by default that you have to remember is class A. The first octet represents network. The last 3 octets represent host. Class B, the first 2 octets represent network. The last 2 octets represent host. For class C, the first 3 octets represent network, and the last octet represents host. So if someone is to ask you a question, which class has the most hosts? Naturally, it will be class A. Which class has the least hosts? It will be class C. Likewise, which class has the most networks? It'll be class C. And which class has the least networks? It'll be class A. So, each IP address is assigned a subnet mask. The subnet mask, if you take a look at it, it matches directly up with what? With the classes and their parts. So the subnet mask define which area is the network and which area is the host. So you could actually look at the subnet mask and differentiate which side is it represents network and which side represents host. And as you get to subnetting, you would understand better how this works. So for class A, as you can see, the default mask is 255.0.0.0, okay, or slash 8. 255 is represented by all ones. So in the class, your teacher could open up a calculator and explain to you exactly what they're talking about and show you how to convert from binary to decimal and then from decimal to binary. So if you get a calculator, you can do it, and you'll see 255 represents all ones. For class B, it's 255.255.0.0. So the 255, that's 8 and 8 16 ones. So that's why you see a slash 16. And class C, you'll see it says 255, 255, 2550. So 255 is 8 ones. It's 8 and 8 16 and 8 24. So that's why you see a slash 24. So let's take a look now. So classes of IPv address. So class A, the first octet, represents the number 1 to 127. Now 127 is reserved for loopback. So the 127 network is reserved. So normally you'll see in a book it'll say 1 to 126 because you can't really assign a 127 IP address to a computer. So class B, the first octet could be any value between 128 and 191. And class C, any value between 192 to 223. So from 192 to 223. For class B, from 128 to 191. For class C, from 1 to 126. Because what? The 127 network is reserved. Now, if you look now, class D is used for multicasting. So like if you want to send something to a group of devices, that's what you use class D for. Okay, and class E is used for testing. So on the side, I give you an example of what a bit notation is, which is the all zeros and all ones. And then I give you what a dot decimal notation is, which is all zeros and all ones. So in class, you guys could practice the class B with the what? All zeros and all ones, or you could use the class C with all zeros and all ones. So you could actually practice that as you're in class. Okay? One of my periods there is now aligned right. So in the class C, you'll see has two dots. So you need to make sure you take out one of the dots there. That was a typo error. So just make sure you do that, because IP address doesn't have two dots inside. So just make sure you do that. Okay, so let's take a look at what we have here, right? I have three separate class A networks. I have a 10.0.0.0. So if you see, the reason why I say network class A, the first octet is 10. So that's my N. My H, or my host is all zeros. So that makes it a network address. So if you have a network ID, or you have an N and zero H's, or there's no H, there's no value for the H, then you have a network address. If you have an N and you have a H, then you have an IP address. So an IP address has to make sure you have what? A network part, and you have to make sure you have what? A host part. All right, so let me make a note of that. So this is a valid IP address. So we're going to, okay, so I just said a valid IP must have a network and a host portion that is not all ones or all zeros. So I'll explain it to you. So for example, okay, if I give you this 10.1234567 8, take a look at this. I have a network address, but my host address is all zeros. Okay, so I have the N but no H. For this to make it a valid address, so if I have to write this back, this would be equal to something like this. But if I decided to now that I want to make it a valid IP address, I would do, so if you look now, my host portion now has an ID or a value. So this now will be equal to, so that's now make it a valid IP address. So take a look at this. So if you have a network ID and the host portion doesn't have any value, so it says the host portion is all zeros, or if the host portion is all ones, then you have a broadcast address. So let me give you an example what a broadcast address would look like. So here you can see my host portions is all ones. So this is known as a broadcast address because my host portion is all ones. This is known as a unicast address because it's unique. So one of the things that you have to understand is that an IP address has to be unique. So I'm going to make a note of that. Must It must be unique. It must be unique within that particular network. This is key. You have to understand this. If it's not unique within that particular network, then you will have duplicate IP addresses, and duplicate IP addresses would not work. So let's go and do something really quick. We're going to assign some class A IP addresses and then we'll test it out. Okay? So for example, I'll go put an IP address in PC0. So let's go do that. And I'm going to assign a static IP address. If I wanted a dynamic IP address, I would use DHCP. So that'll be, and if I hit tab, it automatically fills in the subnet mask for me. And if you look over on the router, you'll see I have 10.0.0.100. So the IP address that's on the router is normally your default gateway. So what we'll do is default gateway in as 10.0.0.100. Okay? Close that out. Now we could come and check what our IP address is. So if I click on run right here and go to the command prompt and I type ipconfig, it tells me my IP address 10.0.0.1. It tells me my mask and it also tells me my default gateway. So that's for PC0. So let's go to PC1. We go to desktop, IP configuration. We'll say this is 10.0.0.2. I'll hit the tab key. We'll put in the default gateway. So now we could actually test communication between the two. So if we go here and we go to the command prompt, we can now ping from here. Ping. So there we go. We get a reply. Okay. So now I can now go. Let's test something out. We'll put an IP in here. And we'll say this is 11. We'll hit tab. And we'll put in the default gateway. Now, take a look. This is 11. So, if I do ipconfig, this is telling me that's 11. So let's open up another host for a second. So we'll open up PC0. Let's see if we could get both of them together. This is 10. This is 11 right here. This is 10 right here. This is showing me that these two guys are not on the same network because I'm using a class A. So because they're not on the same network, I would not be able to ping that 11. So if I come here and I it gives me a timeout because that's an 11 network. I will not be able to get to it. So what we need to do, we need to go back. You could hit a control C if you want to break out of there, guys. So if you want to go back, we have to go back to the host. I will change this to 10.0.0.3. And now, let's see if it works. So we could hit the up arrow key right here, guys. 0.0.3. We could ping that address. So what I'm going to ask you guys to do is go ahead and configure all the other devices, PC3, PC4, and PC5, PC6, PC7, and PC8. And watch what I'll do. I'll take the router configuration, I'll copy this. So I'll do Control C. I'll copy it. I'll go to the router. I'll click on CLI. Very simple. I'll hit enter. And then I'll just right click in there and click on paste. So this is going to run the configuration for my router. And now here I'll do copy, run, start. So this is going to save the configuration on my router. Okay? So that's saved the configuration on my router. So now that is saved, if you take a look at your router, all your links are up. So now, once you put the IP addresses in for all the other hosts, we could test it. So we could put in one here. We could come here. And do 50.0.0.1. If I hit tab, all right, you see it's still a class A, okay? And my gateway is 50.0.0.100, okay? So we're going to close this out. So before, we could not ping across the network. So if we go here and we type ping 50.0.0.100, that's our gateway. You see you could ping your gateway. So if you want to get out from one network to another network, you always want to ping your gateway. And if you take a look again over here, you'll see this is where your gateways are. Right here. This is your gateway. So that's the gateway for the 50 network, 10.0.0.100. So anything on this network has to go to the interface on that router. Okay? So let's go now and let's try to ping one of the IP addresses on the other side. So we're going to try to ping 10 0.0.1. Let's see if it works. Works. So it always drops the first packet. So now you have communication across networks. And one of the things I can show you so that you could understand, if you go to the router and you click on the router, okay, and you could type simple commands on the router. For example, you could type show IP route. And this is going to show you all your networks. See, this is 10.0, so it actually tells you what your network is when you actually go on the router. And it gives you the subnet mask as a /8 notation. It doesn't have it, and it gives you the CIDR notation. It doesn't have it in the form where you would say, hey, look. So we call this here classful networks. So there's no subnetting. So classful networks means that there's no subnetting. So what you're doing right now is classful networks. Okay. Now you could also type show IP interface brief. And that shows you the IP addresses, and it tells you which interfaces they're on the router. So if you can see, my interfaces are up. So the router is a gateway. So it acts as a what? As a traffic route. It routes the traffic from one network to another network. Okay? Now, the goal of this lab is to show you that I can have 3 separate class A networks. And I means that I have to have a router to route between these networks. I cannot just put on one PC on the same switch, unless I'm using VLANs, a 10 network, a 50 network, and a 120 network. They will not communicate. Not because they're all class A addresses, that means they could communicate as all class A addresses. So one of the things we're doing is you're looking at what's known as classful networks. So this everything that we're working with here is called classful networks. We are not doing subnetting. So let me make a note here. This is called classful networks. Okay? This is all classful networks. So you go ahead and as part of your lab, you configure the other two areas, all right? The other two class A networks, configure it, and then set it up so you could ping across. And that's the end of this lab, guys. Hope you enjoyed it, and I'll see you in my next Class B session. So we'll talk about Class B in my next video. Thank you, and enjoy.